Hello everybody, this is Itsu again. Thank you all for your comments and suggestions about this Kacher step down circuit video I did yesterday. I think I have to set some baseline measurements first, because then I know where I stand and which power I can expect for my simple Kacher I have now. I removed all the extra coils for the moment, and I have positioned a pickup coil probe next to the output, and I have made my primary one coil kind of movable along the Kacher, like suggested by Joe FR, to see if there is any sweet spot. And with the sweet spot I think he means minimum input and maximum output. So what I did, I hooked up my multimeter across the both batteries, 25.1 volts at the moment. The terminals are heavily decoupled by ceramic caps. There still is some ripple across it, I know, but I have to do with it now. I have two 1 amp meters in parallel, because I'm drawing about 1.4 amps. So this way I can have an indication about the amps drawn. And then finally I have here the output scope. I have put it to some kind of value which I can measure peak to peak, and I can see then if it gets better or worse when I leave the probe laying like this next to it. So I will now fire up the Kacher. You can see it's burning, and I have running 0.7 amps on both meters, so 1.4 amps at 24 volts. So I have something like, well, it should be 30 watts or something. And I have now this as an output, a nice sine wave, 390 kilohertz. And I've peak to peak 130 volts. So this will be my baseline, and from this I will do some adjustment of the primary coil to see if I can minimize the input and maximize the output. So that is the first thing I wanted to do. Okay, thank you. Okay, welcome back. I found a kind of hotspot, of sweet spot. We went from 130 volt peak to peak, and it's now at 140 volt peak, and this is in this position. I have marked it with blue tape. When I go all the way up to half, the amperage increases, but the output decreases. So this is the best I can do. It's slightly over 0.7 volts. So it's almost 1.5 volts totally at this 24.5 volts from the batteries, and then I have this 140 volts peak to peak. The frequency is slightly decreased, 390 volts. So this is the best I can do, I guess, for this finding this sweet spot on this input. So I will now continue with adding the output coil and see if I can do some modifications there. Okay guys, back again. I have hooked up my 7 turns output coil, my L3 coil, a little bit out of the top. I hooked up my both microwave oven capacitors now in series, also suggested by some users. 1.2 microfarad in series means about 0.6 microfarad now. I have hooked the meter across it again, and I have still the gas discharge lighting arrestor 360 volts in between. I want to test some other. I have another one 600 volt and 1 kilovolt. I can hook up the three and see what's going to happen. And in the worst case I have to make a fixed one or an open spark gap like Joe have suggested. I hooked up my toroid again, and across one of the two 10 volt windings I have my 20 watt 12 volt bulb. So I'm going to hook it up now, and we can see that there is some light, very faint, but that's more than I had. We can see that the spark gap is firing much faster now. The meter shows something like 200 volts. This is the output of the scope. Around 130 volts. Probably the setting or the installation of the L3 coil has some influence on the primary coil, so perhaps I have to move both to find a new sweet spot again. But looking at the meters, the amperage is increased. It's more than 1.6 amps at the moment, 24 volts. But there's some RF and some ripple over here in this battery stuff. But the main thing is that I have some lights now, probably due to the fact that I have halved the capacitance, so the voltage can be increased much faster for the lighting arrestor to fire. Okay, so I'm going to swap the lighting arrestors, see what that does with the output on the toroid. Okay, so the only change is I have now installed a 600 watt lighting arrestor instead of the 350 I had before. By the way, it's not generating any heat after a few minutes of working, so it stays cold to the touch, no warmth at all. Okay, firing up the Kacher again. You can see it's also flashing quite fast. I have a higher voltage. That's logical because it's a 600 volt spark gap lighting arrestor. I have some better light, not much, but it's better than with the 350 volt. I have less amperage running. It's below 0.8, so below the 1.6, and the voltage is stable at 24 volt. Output the sine wave is also steady at 130 volts, something like that. So I'm going to switch now to the 1000 volts lighting arrestor and see what's happening. Okay, I've installed the 1 kilovolt lighting arrestor now between the red plugs. By the way, I have one ground in the system, and that's the ground you see here, which is attached to the outside of this capacitor. That's the only ground that goes to the ground source I have here in the bench. So maybe I should also ground the other one, because we now have a kind of imbalanced ground. But I will first fire up the Kacher with this 1 kilovolt lighting arrestor in the system. Let's see what's going to happen. We can see and hear it flashing, but the frequency is gone down. We can see that the voltage is higher, 650 volt even, and we can see that the bulb is now lighting the same like with the 600 volt, only we can surely see this frequency when the spark gap fires. You can also see the amps running. The voltage is stable, 24, and here we have again the Kacher output. Frequency is lower, 307 now, and also the voltage is stable. So I think this 1 kilovolt is too high for this capacitance. Perhaps I should lower it still even more, but at least we have some lights. I guess I will install the 600 volt lighting arrestor and start tuning the both coils to see if I can find some better sweet spot there. Thank you for now. Okay, welcome back. What have I done? I still have the 600 volt lighting arrestor installed. I have the L3 coil at the same output position. I have installed my variable capacitor across the coil, the pickup coil, with the both red leads, and I can tune the output of the L3 coil, but it has no effect on the bulb. It's about between 35 and 350 picofarad. So that's too low, I guess, to have some influence on the. See, I can tune and show you both. I have some lights in the bulb, but when I now tune the capacitor, nothing is happening, nothing really is changing. So I cannot tune the output coil with this capacitance like I expect it to be. Okay, I will try to put it now on the toroid side, in or out, see if that makes any difference. Okay, done that too. I have this capacitor put on the input across the toroid and at the output, but as expected, no change in behavior to be seen there at all. There's no way this thing is going to be in resonance on the frequency being used. Last thing I tried is to substitute a real spark gap. I made one very quickly with 2 screws and a cap from a bottle, and there we can see that the frequency is the same as about with the 1 kilovolt lighting arrestor, a little bit irregular, and we have the same output. So there's not much changed when using a real spark gap and the 1K lighting arrestor. But this is a very crude one. I liked very much the idea about this carbon rods he used, Joe used from leftovers from batteries. Perhaps I will try to make a spark gap from that to see how that turns out. But well, the first suggestions I tried, I have to perhaps make some more tuning on the input and the output coils to see if I can increase a little bit the frequency, but up till now I have some light in the bulb, but it's not really spectacular when we notice the input of about 30 watts in this system, but progress is being made. I will put this video on, I guess, and perhaps there are some other suggestions. The one by T1000 involves a big modification on the Kacher, so I will leave that for later on, or a next project or something, but I just want to find out if this is any any good replicating because the lights from Joe FR was much brighter when I saw his setup. So there's room for improvement still. Okay, thank you for watching.